Welcome to Chapter 6, Section 6 on solving systems of inequalities. Our objective today is I can graph a system of inequalities and find solutions to that systems. So last chapter we learned how to graph linear inequalities. So basically one of these equations that we might see here. Now we are going to have a system. We're going to have we are just going to do two equations, but you can have as many as you like. And we are going to determine the region that that solution is in. Just a reminder, the only good way of expressing something that is a linear inequality is by graphing it, because we end up with a region or a half plane that we find all of our solutions in. Now we're basically going to cut that half plane into another section, and we're going to have to pick out of 4 sections which section our solution is in. So I'm going to try to be really systematic about that, and hopefully we have a good understanding of that by the time we're done with this lesson. So taking a look at this first one, obviously, hopefully these are pretty easy. We see a line that's going to be horizontal and a line that's going to be vertical. And so we are going to start by graphing our first line. And I'm going to try to, as we go through this, help you think through how to get that appropriate section every time we do this. So y is greater than -1. Well, I remember from last chapter that this means I'm going to have a dotted line. I know that y is -1 right here, and it's always -1. So it's going to be a horizontal line with a slope of 0. So I've got my dotted line now. Now I need to, I'm going to pause. I'm just going to pretend that this second equation's not here. And I'm going to say, well, what is the solution to this equation? And in some way, I want you to mark that. Now, in years past, I've had students stripe that section, and then for the next one, they stripe it another way. I'm going to try it a little differently this year. Hopefully, it's less confusing. But if those stripes work for you, to stripe this section now and then to stripe your other section later and figure out where you have that checkered pattern, then go with it. What I'm going to do now is I'm going to say that y is greater than -1. Well, that must be up here. I'm just going to do something really light, okay? Something really light to say my solution's got to be up here somewhere. Now, x is less than 0. That's another dotted line. And x is 0 is right here. So now we need to figure out where this is. Well, if x is less than 0, then it's going to be over here. And my question is it going to be region A or B? It's got to be somewhere on this side of the line, right? And I see that I've got shading from my previous thing here, and I'm wondering, where is the shading overlapping? Where do I have a section that is a solution for both of these equations? And if you notice that I was a solution to the first equation, and it's a solution to the second equation, so I am going to mark this really darkly to say this section over here is my solution. Now, I've given you 3 points here to say, is this part of your solution set? You can test them up here, but the easiest way, I think, is just make sure that you have the right section and then see if that point's in that section. So 3, 4 would be a solution to the first equation, but it is not a solution to the second equation. 3 is not less than 0, meaning that it is not a solution to this. How about -2, 5? Well, you'll notice it's in our darkly shaded region. And if I plug it in, -2 is less than 0, and 5 is greater than -1. So there are 2 ways to check points that I give you. How about -4, -5? Well, it looks like it is a solution to the second equation, but it is not a solution to the first. So it is not a solution to our system of equations. Now let's look at the next one. I'm going to move a little bit faster. And you can stop and pause if you need to. So I've got a slope and a y-intercept. This is I'm going to do an open dot because this is not equal to. And I'm going down 2 over 1, down 2 over 1, down 2 over 1. Like I said, I mean, here's where it is. This is so important that we have straight lines because now we're talking about regions where solutions live in. So if I don't have this right, I really won't be able to evaluate where the points are that make this true. Okay, and let's think about this before we move on. So y is greater than this. Well, that's above the line. If you want to test point 0, 0, if I put 0 in here, 2 is not less than 0. This would be a full statement. So our solution is over here for this first one. I'm just lightly shading that region to remind myself the solution's got to be over here somewhere. Now I'm going to do this. And so y is less than x plus 1. This is going to be a solid line. My y-intercept is right here. This is going to be a closed dot, and I'm going up 1 over 1, up 1 over 1, up 1 over 1. So if we were thinking about a system of solutions, of equations, our solution would be here, but this is inequalities, so we are thinking a region. So it can either be A or B. The question is the solution above this line that I just made or below this line? Well, y is less than this, so that means it is below, right? You can again test 0, 0 to say, is it below or above? Either way, if our choices are A or B, since this is definitely below, this is our region that we are shading. And real quickly, 3, 4, well, only because this is a solid line is this a solution. Yes. How about -2? Definitely not. How about -4? Definitely not again. Neither of those were even one solution to another system. Okay, so this first one, I see this is going to be a dotted line. So I am starting here, up 1 over 1, up 1 over 1, up 1 over 1. Let's make a beautiful line. Okay. And so where are my solutions going to be? Y is less than this, so the solutions are over here. If you test 0, 0, it's going to work. 0 is less than 1. 0 is part of the solution set. Now, like always, you have a choice. Do you want to put this in slope-intercept form, or do you want to use your x and y intercepts? For the heck of it, I'm just going to use my x and y intercepts. I'll make this 0, divide by 3, x is greater than or equal to 4. So there is one of my intercepts. And y is greater than or equal to 3. There's my other intercept. So my line is going to be like this. The big question then is this A or is it B? Now I'm going to plug 0, 0 in here because it always makes me a little nervous when y is not solved for. So if I put 0 and 0 in here, that's going to make this whole side 0. 0 is not greater than 12. So 0, 0 is not part of my solution set for this second equation, meaning that the area A that is where 0, 0 is not has got to be where my solution lives. Okay, now let's test 3, 4. 3, 4. Oh, it's living on a dotted line, which means no, it is not part of my solution set. It's really close. It's like sitting like right next to my region, but it is not part of that region because it is on a dotted line. How about this? -2, 5. Well, that's definitely not. How about -4, -5? Well, that's not either. Something like 4, 2 would be perfectly in my shaded region. Remember about these shaded regions too is that they go on forever this way. Wherever this line is for all of time is going to give us our shaded region. So there's really infinitely many solutions. We're just shading what we see on our coordinate plane. Hopefully that gives us all the relevant information we need. Okay, a lot of these should be pretty easy. Go ahead and pause the video and try them on your own and see if you can do it now. That'll really help you see how you're coming along. I'm going to go ahead and do them on here, but I really want you to pause and try it yourself. So I don't know why these are here. I think this was copied from a like worksheet or something, but those really have no relevance. Y-intercept, up 1 over 2, up 1 over 2, up 1 over 2. Solid line. Y is less than this, so it's going to be somewhere over here underneath the line. And Y is greater than -3, so -3 is down here. This is a dotted line. And A or B, well, Y is greater than -3, which means it's got to be this little slice right here. Is 1, 3 part of it? No. Is -2, 2 part of it? No. Is 3, -5 part of it? Still no. Okay. X is 2, solid line. X is less than 2, so it's somewhere over here. Now, Y is less than this, so a dot at -1, my Y-intercept, up 2 over 3. And here is my line. Now the question is A or B. Y is less than this, so that means it is underneath this line. It's got to be B. So notice we're just trying to simplify this as much as possible. Really, we're asking ourselves, trying to get this down to either or, 50-50, A or B, to make sure that we are getting this right every time. 0.13 is not part of the solution set. It has to be in this darkly shaded region. -2, 2, still not part of it. And 1, 2, 3, -5, still not part of it. And finally, I've got a y-intercept of 1. And this time we're going down 1 over 1. Oh, and these should be open dots. I'm so sorry. Open dots, open dots. We're going to redeem ourselves by making this a nice dotted line. Okay, so the solutions are not on this line, but they're below or above it for sure. Y is less than, meaning it's underneath this line. And let's graph this one. Again, open dots here. Up 1 over 2. Ooh, that's a beautiful solution to a system of equations. But it is not going to be part of our solution to this system of inequalities, because these are both dotted lines. Okay, now the question is A or B. Well, y is greater, so it's going to be above this line. So this is our region that we care about. Okay, and let's check our points. 1, 3, not part of it. -2, 2, that is part of it. And 3, -5, not part of it. Okay, real quick, couple word problems, then we're going to be done. Now, I think the toughest thing about this is figuring out how to graph the lines. This one particularly is a question that math teachers love to ask because it's a little different than anything you're going to do in any other sections. So Mr. Flowers is on a restricted diet that allows him to have between 1,600 and 2,000 calories per day. Ooh, the word between. I know that word. I think that is something like this. 16,000 is less than or equal to, what are these calories? Let's just label that C, which is less than or equal to 2,000. So let things jump out at you. We know the word between. The way we represent that in this math class is like this, always a compound inequality. His daily fat intake is restricted to between, oh my gosh, there's that word again, 45 and 55 calories. Grams. So let's do it again. Is less than or equal to grams, which is less than or equal to 55. What is the calorie and fat intake that are acceptable? Okay, so let's go over to this graph so we can represent it. Remember, this is really the only way we can represent well what this solution to this system of inequalities is. So it's going to be between these two numbers. So what I'm going to do is I'm just going to draw a line where 1,600 is. It's like right there. And I'm going to draw a line where 2,000 is. It's right there. And my solution's got to be in between here somewhere. Well, let's draw our other. These are going to be horizontal lines. And I've got one at 45. Well, that wasn't perfect. And one at 55. And where do my solutions live? Well, it's got to be between again. Where do these shaded regions overlap? It's right in here. Right in this box. This is where Mr. Flowers can find the ratio of grams and calories that he is allowed to eat on his restricted diet. That one was weird, but you're going to see one like that again. So look for this word between. That's kind of the dead giveaway that we're looking at a problem like that. Maria has 150 in gift card certificates to use at the record store. Okay, so she's going to use, something's going to like equal 150. Okay. She bought fewer than 20 records. Well, okay, I bet we're going to add something together to get 20 here. Each tape costs almost $6 and each CD costs almost $9. How much does each type of record she bought? Well, it looks like, and the graph is a dead giveaway that our variables here are going to be tapes and CDs. So let's just call those X and Y. Now, there's definitely a money equation in here. Money, money, money. So I think I can write this first one. Money times the number of tapes she bought plus money times the number of CDs she cost. Well, that's got to be less than or equal to the amount of money that she has. This cannot exceed the amount of gift certificates that she had. And then she bought a total of 20, so I must need to be able to add this and this together and get less than 20. So X plus Y has got to be less than 20. Now this feels like a really complicated substitution problem, but because of these inequalities, we can't set this up as a substitution. Or we'll say it differently, there's no reason to, because they are they're, who cares where they intersect? We're looking for a region where we find solutions. So let's go ahead and graph this guy. This is going to be a lot easier to graph than the other. I'm going to rewrite it like this. Y is less than 20 minus x. I just subtracted x from both sides. That's going to be easy to graph. So my y-intercept is 20. That's not going to be a solution. And I'm going down 1 over 1, which is the same as going down 5 over 5. Down 5 over 5. And we're going to hit right there. And so I've got a dotted line. And it's less than, so it's going to be somewhere in here. And these are a lot tougher to graph, but we can do it. So I am going to, how do we want to do this? Well, let's go for it. Let's write this in slope-intercept form. So 8.95y needs to be less than or equal to 150 minus 5.95 x. I didn't leave myself with very much room there. Okay, now we've got to divide by this. This is the annoying part, but this will at least give us a good idea of where this should be. And let's see if I have a calculator handy. Probably don't. Okay, so I'll just use my computer real quick. Okay, so we've got 150 divided by 8.95. That is, a really annoying number, but let's call that less than or equal to 16.76 minus, what is 5.95 divided by 8.95? Well, that's, let's just call that 0.665x. So you might have wanted to try to use your x and y intercepts. That probably would have been just as well, but I'm going to get a closed dot somewhere here at 16, and this is going to go down like 67 cents and over 1. I'm really interested in what my x-intercept is here. If I do 150 divided by 5.95, I see that my x-intercept is about 25, just a little bit over. So that is going to help us make this line. This is going to be a solid line. And then the question is, where are my solutions? Are they in this tiny a or are they in this b? This is a less than statement, and nothing weird happened when we put it in slope-intercept form, so it is going to be under this line. So here's where she can be. These are the numbers of tapes and CDs she could buy. For instance, she could have bought 5 tapes and 10 CDs. She could have done 10 tapes and 5 CDs. And everything in here could be a possibility for that. She could have just gotten 16 CDs and no tapes. But this helps us to see a region of possibilities of what this solution can be. Well, I've talked enough. I hope that was helpful. If you have any questions, let me know, and you should know what to work on next.